Section 1.1, Linear Equations. In this section, we're going to be talking about basic terminology of equations, linear equations, identities, conditional equations, and contradictions, solving for a specified variable, literal equations. Equations. An equation is a statement that two expressions are equal. So the things you're looking at in these three examples, that it has an equal sign. The first equation is x plus 2 equals 9. One thing I want to point out is that the exponent for x is 1, which means there's one solution for that particular equation. In the next example, we have 11x equals 5x plus 6x. If you notice that the highest degree of the variable x is also a 1, which means there's one solution, or maybe infinitely many, or no solutions, depending upon when you solve the equation. In the last example, we have x squared minus 2x minus 1 equals 0. This has an exponent of 2, which means that there's a possibility of those two solutions. Now, to solve an equation means to find all numbers that make the equation a true statement. These numbers are the solutions or roots of the equation. A number that is a solution of an equation is said to satisfy the equation, and the solutions of an equation make up its solution set. Equations with the same solution set are equivalent equations. Addition and multiplication properties of equality. If we let the variables a, b, and c represent real numbers, then we can say the following. If a is equal to b, then a plus c equals b plus c. And that is, the same number may be added to each side of an equation without changing the solution set. Again here, we're going to let a, b, and c represent real numbers. If a is equal to b and c does not equal to 0, then a times c is equal to b times c. And that is, each side of an equation may be multiplied by the same non-zero number without changing the solution set. A linear equation in one variable. A linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers with a not equal to 0. Linear equations. Now, a linear equation is also called a first-degree equation since the greatest degree of the variable is 1. If we take a look at the first example called linear equations, there's 3 of them here that represent a first-degree equation. Here we have 3x plus the square root of 2 equals 0. The exponent for the variable x is a 1, which means that if we solve for this equation, we're going to get a solution there. 3/4 x equals 12. This is also considered a first-degree equation. 0.5 times x plus 3 equals 2x minus 6. Again, that is a first-degree equation. Now, below that are examples of non-linear equations or non-first-degree equations. So here's an example. Square root of x plus 2 equals 5. The exponent for x is not a 1. Over here, this is 1 over x, where x is in the denominator. This is also considered a non-linear equation. Here we have x squared plus 3x. This has a degree of 2, therefore it's not a linear equation.